Mastercam basically had 5 key areas that they wanted to focus on for the 2019 release. And you guys can see all of those there, but really what those mean are from a job prep setup feature is, different. We have MBD support in 2019 now, a couple new model import tools, easier ways to set up your fixtures in different parts of the job, which I'll get into a bit today. The validation means, enhancements to the Mastercam simulator. I'll be talking a bit about how we have some new simulation options for standard turning centers. And there's a couple other areas I'll cover in the verify in there. And then job documentation. That's mainly, setup sheet enhancements, being able to record from the simulator, and a few other areas. We have some new ways to view parts, like a section view inside of Mastercam instead of just in verify now, and a couple more features that I'll get to today. And then as always, we're focusing on CNC programming and making tool paths, more efficient, better motion of the tool path, so you're getting better parts off the machine, and a few other features that I'll also cover. And then lastly, we have some new cutting tool support. 2018 added some of the Machining Cloud and Coral Plus support, and we're expanding on that with some new 3D lathe tool support and some additional support on the cutting tool side, including the Sandvik Coral Turn from the prime turning that I'll get into later as well. So let's hop out of the PowerPoint here. And being a preview webinar, it's not going to be as in-depth as ones we'll do later on. Basically, our plan of action here is Mastercam will be releasing 2019 in the first part of June. And then we'll be doing in-person rollout seminars. People from the original Illinois, Wisconsin, Iowa Mastercam territory will be familiar with those. And after talking with John and Justin in Indiana, looks like they've held some good events down there as far as rollouts go, and we'll be continuing that as well. And then once all the rollouts complete, for anyone that wasn't able to attend or maybe too far of a drive to get to an in-person rollout, we'll be doing in-depth webinars basically by product after all those webinars after the rollouts are completed. So if you go on our YouTube channel, I think they're about 2 hours long a piece, getting more in depth into the software. And we're certainly not going to be there that long today. It's about a little before 10:15 now. I don't imagine seeing this going past 11 o'clock or noon Eastern. So I'm going to do some general Mastercam items. We'll get a little bit into design, a little bit into mill, a little bit into lathe, and then we'll kind of open it up for questions. Advanced topics like mill turn and multi-axis and stuff like that, we'll probably leave for some future discussion or at the in-person rollouts. So let's go. I got a couple sessions of Mastercam open here. So let's start getting into some meat of this, and I got to be mindful of, I know there's always a bit of a lag on these webinars, so I have an audience view here, so hopefully it's not too choppy or anything like that. And those of you that have attended ShopWare webinars in the past, some of these parts may look familiar. I try to leave the parts the same so we can focus on the actual changes in Mastercam and seeing some, fancy new shiny part that you're trying to figure out where it is or you want to get a copy of it. So the first one I want to cover here is in the visualization part of Mastercam. So if you go to the View tab in 2019, there's a new option here called Advanced Display. And basically what that does is if I expand this window here, we can essentially now assign different colors to the various motion a particular tool path will have. So, before you always had the yellow for rapid and blue for cutting motion. But if we turn Advanced Display on here and I zoom in, you'll see now we got green for some helix moves here. Let me turn off my wireframe so we can see that a little better. And then the red motion here is an exit to a toolpath till it repositions. And then the orange, you can kind of see on there, this is a dynamic OptiRough path. That's basically where it's going back to wrap around to climb cut again. And in the colors tab in the system configuration, you do have control over what colors you want those to be. You know, maybe you don't want to see the reposition moves as a different color and you're more concerned about the entries, exits, things like that. This has already helped me a lot in looking at particular toolpaths or certain machines, because, you know, if you go on the linking parameters of OptiRough, let's say, you know, you have all these different leads. And before, when everything was all blue, it was kind of hard to see changes that you were making to those values on how it actually affected the motion of the toolpath. And now, since those show up in red, it's a lot easier to see what those values correspond to. So the next one is kind of a small one. I'll turn off the toolpath here, but we all know what analyze distance is. So if you right click in Mastercam, it's built into the default right click menu. I have my 2019 set up completely default as you'd get it out of the box, but you can customize these menus really as much as you want. I've seen people put the entire Mastercam interface under the right click menu. But analyze distance now, in the past, you always had to click on the next spot you wanted to get a specific measurement. But now in 2019, it'll snap to wherever a snap point is available. So it can respect edges of solids or midpoints, or you can use, you know, those additional selection tools we've added where you hover over a location, it puts the green dot and then another green dot, and then you get the red midpoint. But I don't need to keep clicking and unclicking to get new measurements from an original point. So if I do click and it completes the measurement, then it works just like it did in 2018, where if I click again, I'll start my new origin location for the measurement. So I definitely think it'll help as far as analyzing models and picking up distances moving forward. And also what we added, I believe it was 17 or 18, if I turn the toolpath back on here, on the Home tab, we had Analyze Toolpath. And the Analyze Toolpath was nice in that it showed you, you know, what operation the toolpath was coming from and other pertinent settings of the toolpath, you know, what your spindle speed was. But what we added for 2019 is the ability to display the tool and the holder. So as you can see on here, if I zoom out, I can see my tool and holder right on as I'm analyzing the tool path. You can turn both of those options off, and then you get the same functionality that you did in 2018. And then also, you know, if you have a more complex part or tool path, you can turn down the opacity of the tool to get a little better view. So it can kind of be a quick check. You know, people are probably used to using the check holder C-hook or other clearance things like that, where you can basically analyze the tool path now and get a quick representation of where that tool and holder is going to be in reference to the part as you're checking out the tool path. So one feature request we've had over the years is, once we added in 2017 all these quick masks on the right-hand side, there were a lot of quick masks that a lot of people didn't want or didn't use. And, you know, depending on the resolution of your monitor, they could spew into a couple rows. So now if you can go to File, Options here, or the quicker way to get there is you can right-click anywhere up in the toolbar and go to Customize the ribbon. And then the options is here on the left. This is also where you customize the interface for those that aren't familiar with it. You can create your own toolbars at the top. The context menu is customizing the right click. But if you go to options here, now I have control over what quick masks I want to see. And there's a couple that are turned off by default, which is surface curves and polygonal meshes, which is an STL selection. So, if you never deal with surfaces or other things that you don't want in the quick masks, I really can't stress enough how those quick masks can be handy in a day-to-day use. Selecting all wireframe, for example, and moving it to a different layer can really speed up your workflow. But being able to clean that up is nice. Some people may not know, but in the system configuration options, you can also set the opacity level of these, because if you hover over it, it'll highlight more. But you can set it basically so that it'll disappear completely unless you move your mouse over to that particular area. So one thing that I've actually asked for in the past and wasn't sure why we didn't have it in Mastercam is kind of a simple copy-paste functionality when you're going between levels. So let me turn on some wireframe here. So I got my containment boundaries where I used curve on all edges when I was originally programming this part. Let's make a new level and we'll call it just copy to or whatever I want. So I can select what I want to copy, and I can copy the items, and it's going to tell you only geometry will be copied and toolpath won't be moved. But now I can right click right on the level and say paste entities there. And now as you can see, I got 12 entities on that level 12. So I did that kind of quickly there, but if you right click on the new level, the new options here is to cut, copy, paste between the levels. And before you'd have to select, right click in here, say move to a level, remember what level you wanted to move it to, or create a new level, and it can really just speed up organizing files, which I thought was a nice enhancement. And I don't know if I've mentioned this already or not, but I kind of pick and choose from the What's New document and the What's New website that Mastercam has for a preview webinar like this. So I'm not going to be covering, everything that's in there today. So, and I'll show you guys at the end some ways where if you really want to do a deep dive into everything that's new, where you can go to do that. So another small one is as we stay in the level manager here. So let's say we want to turn off the wireframe and maybe part of this vise here. Now, if I turn those off and I say turn all on, it'll basically now, and it works the same for all off as well. But if I click turn all levels on, and then I turn it off again, it's going to remember the state of the levels I had on or off. So, it's another one where if you have a complex model where you only want to have certain levels on at a certain given time, instead of having to go through here and pick all the different levels you want to control, you can basically have kind of a quick state of what is on and off. So, as you can see there, I'm still clicking turn all on, which before it would always just turn everything on, and that was the only option. And if you kept clicking it, nothing happened. So it basically alternates between those states. So if I do all off, since I haven't determined an all off, it'll still remember what that setting is. So that's just kind of some of the general system enhancements I wanted to cover. Let's get in here into some simulator options. So let's turn all these toolpaths on. I'll turn my stock model off there, and let's go into verify. A couple cool enhancements we've added into the simulator here. So the first one I want to cover is this option down here. So it's a new option added into the simulator called Capture Replay. Now the only caveat to this is if you click the fast forward button, it's still going to calculate the toolpath because it's essentially recording the motion as you fast forward it. So that was with it turned off, and it just does what Mastercam did in the past, and if I rewind to a point, it just puts the tool back to where it was. But if I reset this and turn that on and hit fast forward, and let's turn on color loop as well. So even though I hit fast forward, it's doing it as fast as my computer will do it. I have a couple-year-old laptop, but it does have some decent specs, Quadro 2000 card and 24 gigs of RAM. So as it's going through here, I can now pause it, and if I drag, and let's use this new tool, which I'll get into in a second here, I can rewind it, or we can go that back here. So if I zoom in here and rewind, it'll actually show the reverse of the cutting motion I did. So I don't have any collisions or issues with this particular part, but I could see this being handy on if you do, in the past, you see that dreaded red swipe through a part, maybe you didn't set a retract height properly between tool paths or similar. You can now have basically granular control over at what point of the tool path you're going to see that material removal. And then another option that kind of ties into this is you now have a slider here in the bottom left-hand side, which is basically a zoom function. And it's kind of hard to see because my part's dark. But in the bottom of the screen here, you have basically a timeline view. So everywhere that's gray in this section is what I'm currently seeing in kind of the main bar in my screen here. So as you see, if I zoom out, if I zoom all the way out, this bar is seeing the entire tool path. Whereas if I zoom in and hit play, it's only showing me this small section of the tool path. And I think since I turned my color loop on late, that might be some feedback I'll have to give to Mastercam because it should still be yellow in this particular section. But I'll attribute that to user error. But as I zoom in here, since you only see this small section, as I move through the tool path, because if you have a bunch of operations you're verifying, without the zoom function in the past, if you would move this slider just a little bit, you would get a lot of motion in a very short amount of movement. So it'd really be hard to fine tune that area of the verify that you were trying to see. So I could see that as being pretty handy moving forward. Could try it.
I was just going to double check it out.
So we had a question on when I did the copy paste here. If let's make another level real quick. If I do Control C, Control C and Control V I think will work. So and if I hover over the functions here, it does list Control X for cut and Control C for copy. So you can use keyboard shortcuts to copy paste between the levels. A few other ones here in kind of the general section. I covered the couple new things in the simulator. Going down my checklist here. Section view. So what we added in here, and this took me a little bit to figure out from reading the what's new to how it actually works in practice. But let's go to my planes tab here. Now the section view works off of different planes. So I do have section view turned on here, and I was wondering why it wasn't doing anything or not giving me any controls. The section view is based off of how your plane is defined. So if I created another plane here called the mid-top view, where I'm basically halfway down the part, but I'm still in the same XYZ orientation. If I turn my plane to that plane and turn on section view, with section view turned on, then you can basically pick on the plane that you want the section view to be active from. So you can show caps or not. So the caps is basically, since you're slicing through the model, it'll basically cut it at that point that the plane is at. So if I go back here and turn this particular tool path on, since I have the section view, it's also going to cut the tool path based on that section. So, if I have this back on the original, and being a full 3D OptiRough toolpath, it's hard for me to see what's going on in that toolpath in the lower section of the part. So typically in the past, I would go to maybe backplot, fast forward to the point that I wanted to see and kind of check out the toolpath from there. But even then, it would be basically hard to see what the tool motion is in that particular section. So if I turn the section view on to the place that I sliced the model by creating the plane, and basically all I did was a dynamic plane and edit it down to get the slice section I want. And it would work the same if I wanted to go side to side instead of top to bottom like I'm going here. But now since I have all that cut away, I can easily see now what sort of tool motion I'm getting in the bottom of the part without seeing the rest of the tool path in there. So I thought that was a pretty cool enhancement that they added to this version. So the next one, a lot of people were getting feedback from a visualization point of view, and I'd see if I'm hovering over the solid here and hovering over different faces, I am, sometimes depending on the color of the solid or how many things you have going on the screen, it was sometimes hard to see. So if you go to the configuration menu now and go to the screen tab, and it's not on by default, but I can turn on what's called glow highlighting now and say okay. And you also have control over the color of the glow in the colors tab over here to the left. Yes. So now with glow highlighting, you can really see that's quite a difference on what my hover highlighting's like. Very similar to what I've seen in SolidWorks. But now as I'm cutting through, even with the tool path on the screen, it's really easy for me to see what face I'm on the given part. Which I thought was pretty cool. Okay, that's all I have for system. Let's move on to the next part, because I have some stuff set up in here. Let's close out the simulator. So I have another just generic 2D part that'll be easier to show. Some of the things I'm going to cover in, we're going to go over some design items now. So I have some geometry over here that I just drew for example's sake, but one of the feedback we got, because on the model prep tab here, we had an align function back in 2018, but now you have basically an expanded capability on how the align function works. So what I originally did here was I did modify feature, and I created a body based off this open pocket over here. But so before, if you wanted to mate those faces together in 2018, you'd have to pick the mating point, select the mating point on the target body, and then maybe adjust the dynamic gnomon to get the piece exactly where you want it to. So, if you have an assembly or a file with a bunch of different solid bodies, you'd be doing a lot of adjusting to get stuff exactly where you wanted. But now I can use the feature called align to face. And now it says select the face on the solid to be moved. So I want to move this solid over here. And now it says modify the reference point, which you could do in the past, but or I can select the face I want to move it to. So it's moving it back to its original location, but I still have control here with the dynamic gnomon if I did want to modify where that location was. But before, I purposely, when I did this, is I rotated this part kind of randomly in space, because before, using the align function in 2018, it would mate it to this face over here, but in that weird angle orientation. But now you have some options here for coincident, perpendicular, or parallel. So the coincident will basically figure out what this plane is at and match it up to the solid on this feature over here. So the next one I want to cover is called solid hole. So on the solids tab here, you have a new function called hole. So before, in the past, if you wanted to create, say I want additional holes, there's a design change to this part and I need to add something to here, you'd have to draw a wireframe, do an extrude. If it was a countersinked hole, you'd have to draw multiple pieces of wireframe and extrude them different distances. But now with this hole function, I can say hole. So now it's saying, since I have multiple solid bodies, what target body do I want to add the holes to? That's what I want to do. Now, position. So I don't have any wireframe on this part right now, so let's use some of the expanded selection tools to add a position in here. So I can select maybe the center point of this hole, center point of this hole, and now I get my location right here. So that's where I want to make that hole. And I can assign a distance. And I got to hit enter when I'm done. So if I want to add more points here, I could, but let's just do the one for example's sake. Now, right away, it's going to put a hole there because the default setting here is just a standard simple hole with 1/4 of an inch. But I can modify this. Let's say we want to do a counter bore. And now I have control over, okay, what's the diameter of the counter, or the diameter of the hole? So let's say that's, I don't know, let's make it 30 or 300. It's going to automatically adjust the counter bore diameter, but I can adjust that as well. Let's say 0.75. And then what I want my counter bore depth to be, let's say maybe this is a shallow one, and we'll just go 100. And as you can see, as I update these values over here, it adjusts what that counter bore is like. So, if you're working off of a print or anything like that, you can really speed up what orientation or how you're creating the holes. If it's not a through hole, like this one's going all the way through because this part isn't quite an inch thick, what you want your bottom angle to be. Do you want to add a chamfer to the top of the hole? And, all of this in a single operation where, if I had to do this in 2018, it would be probably 5 or 6, 7 steps. So definitely a handy enhancement to the design side of 2019. Understanding your question correctly, the only way I would see it would not go to the correct side would be if it's not a watertight solid. So Mastercam is basically, when you have a solid body, think of that as it's a solid entity. So that back side of the feature really isn't capable unless it was like a sheet body solid. So yeah, I was kind of playing around with different features in there on that align function, and I couldn't get it to not align to the correct side of the solid. So I hope that answers your question. So going over to, I drew some wireframe here as an example. We all know the tried and true divide function in Mastercam. They now split that back out from the standard trim command to just divide here. And before, you'd basically pick on what you don't want. But the small functionality enhancement we added to this is you can basically click and drag to what you don't want. So let's say this is all my reference geometry off of a print, and I want basically the outer boundary. I can just click and drag through here and basically get rid of all of anything I don't want by just dragging the mouse. And anywhere that gray arrow I'm drawing is where the divide function will pick up. So I probably did that too fast for the webinar to keep up with me. But again, you just click on divide there, click where you want to start dividing, and basically drag through entities that you don't want. And it defaults to trim, but you can also set that to break as well. So that's enough design and system stuff. So I have just a simple part here, but I want to bring in a different example because I wanted to have some bosses for chamfering toolpath. So anyone that's been doing chamfering in Mastercam for a long time, it can be a pain if you have a lot of different features and you got to adjust your lead in, lead out per chamfer. And depending on the piece of geometry, you'd really have to get into editing all those different areas. So we added basically an all new toolpath in 2019 called Model Chamfer. And people that really want to get into this new toolpath, there's a really good video I can link to. I'll put it in the description maybe of when we post a recording of this on our YouTube channel. But the Mill Product Manager at Corporate has a good about 15-minute video on basically all the options on this. But let me show you what I did in this one, and we can do maybe the inside of this part as an example. So if you click on Model Chamfer, it right away takes you to this tab, kind of like how 3D Mill works, where it's basically forcing you into some geometry selection. So you still have to go in here and pick what chains you want to chamfer. So I use the linked edges command to pick basically the outside of this part and the back side here. And then you have a solid model. So it's going to pick up the solid model automatically based off of your chamfer geometry, or your chain geometry, I should say. And be mindful of this is designed to work off of solid models. That's why it's called Model Chamfer. So I basically assign what I want my clearance to be to the model. So that's the clearance, as you can see over here, between that post and where it starts to chamfer, where before, it'd be kind of a guessing game where you'd have to know the diameter of your tool, how far you wanted to start the lead in or lead out to avoid violating other areas of the model. And then if I had some additional work holding in here, maybe a clamp or something like that, I can add additional models as avoidance here, but I don't have to worry about that on this particular toolpath. And then they basically simplify some of the parameters in here. So you have kind of the standard, how we updated, being able to define the chamfer width and what your offset is on the chamfer. It does support depth cuts, and then they simplified the lead in, lead out a bit. So you can still adjust the start and the end of the contour, but the main setting here you want to be mindful of is what the fitting distance is. So that's basically a distance of a range of what I want to give Mastercam to allow it to fit my lead-in values here. So I have a 1/2 inch radius in and out with a 45-degree sweep on my lead-in, lead-out, and then I have the fitting in there for the lead-in, lead-out. And then the linking parameters page has also been simplified quite a bit in that you can assign a clearance plane. Sorry, someone's on the phone walking by the conference room here, distracting me. So we have the clearance, retract, and then just what you want your feed plane to be. So then you get a result like this. So without having to, chain these individually and adjust lead in, lead outs, you can really quickly get a chamfer on there. So I can go to Model Chamfer here. That's kind of a live example. So what do I want to chamfer? I can use the linked edges command that we added in Mastercam, and let's say I just want to chamfer from, so I can chain around the geometry here. Let's just say we want to do part of this. It's already 10:45, so I don't want to run too far over. So I have my solid model. It's going to remember my cut parameters from previous. So I can just say do it. And now I got a nice lead in, lead out chamfer of that particular section. And I was hoping if I would try this, if it would get close to that model over there, but it obviously doesn't, or it wouldn't calculate the tool path from that location, but it's still respecting that distance I had for avoidance of the part model. So, if you have a pretty complex solid model where you have a lot of chamfering you need to do, you basically just want to pick all the edges you want to chamfer, set up those parameters. And as you guys do try this, just remember to be mindful of, on this page, what the clearance is you want to the actual solid. 50 thou is quite a bit. You can tighten that up really as much as you're willing to push it. And then adding the avoidance model if you need to. And then lastly, my Mastercam defaulted to, I think, 100 thou here instead of 1/4 of an inch for fitting distance. And since I had a 1/2 inch lead in, lead out, but only 100 thou down here, it was not calculating any tool path. So after talking with Mastercam a little bit, you basically want the fitting distance at a minimum to be half of what your lead in, lead out distance is. So since I'm at a 1/2 inch here, 1/4 inch would be the minimum of what I would want to set the fitting distance to. So just be mindful of that as you try out this new tool path. A couple things I'm not really going to go over in depth, but I just wanted to talk about. First off, people might be used to using the check holder C-hook when you're checking depths, especially on a 3D model or parts where you're getting really close to the holder, clearing the geometry of the part. Check holder is now built right into the mill toolpath menu, and it's been updated and expanded a bit. And I won't run through this entirely, but it has some expanded capability here, and I definitely recommend checking it out. And it'll display safe and unsafe motion like it did in the past, but the testing is now multi-threaded, so it's, now that it's fully baked into Mastercam, it's just overall a better performing function. Even though it was useful in the past, it's just better than it has been. And if I go back to the monkey part, one thing I forgot to talk about here earlier was the skip pocket smaller than. So on the OptiRough here, before skip pocket smaller than was based on just a size. So you'd have to know what the size of your pockets were in order to skip the ones you wanted to. Where we've readjusted that now, and it's on the transitions page. And the skip pocket smaller now is now based on the size of your tool. So I have a 1/2 inch bull end mill for the roughing pass here, and my skip pocket smaller than now, so 115% is 0.575. So instead of having to know what the geometry is of the part, I basically just tell it, I don't want to dive my 1/2 inch tool into a pocket that's, barely bigger than the tool. So that was kind of a small enhancement that I think will save people a lot of time when doing more complex 3D work. Now getting into another new tool path. So we all know the high-speed scallop. So if we go to tool paths here under 3D, it was here just called scallop. And, it was generally a pretty good tool path. But if I look at this tool path here, I was getting sharper motion, and I have the glow highlighting on. Let's turn that off because it'll be easier for me to show this to you guys and gals. Where, I'm getting kind of some sharp motion between the passes here, depending on how I was calculating the tool path. Maybe some sharp motion over here. Depending on where my containment boundaries were and allowances, I could get some jagged motion at the top of the part. So basically, instead of trying to modify that scallop, Mastercam basically went and rebuilt Scallop from the ground up. So in the 2019 release, we did not remove the high-speed Scallop, and it's basically just another option in here called equal Scallop. So same settings, same step overs, everything like that. Here's what the equal Scallop looks like. So you can see I have smoother motion between the passes here. I have smoother motion as it's going over the ribs here. And since it is, part of the reason why they called it equal Scallop is it's basically better at maintaining whatever your set step over or scallop height is. So if I go into the parameters here, if I set it to spiral, it'll never really transition between tool paths. It'll always stay in constant motion. There's this smoothing function that I have turned on that's not an original scallop, and that's where you can get the smoother motion between passes, like over here where it hits those peaks and valleys. And basically those two settings really kind of reinvigorated on how this tool path worked. This tool path actually started, one of our customers was doing some micro machining for medical parts, and they needed a really smooth surface finish, and just really no matter what settings they were able to get in the old HST scallop, that they just weren't getting the motion that they wanted. And the last option here in equal scallop here is this projected boundary smoothing distance. So that's basically applying a distance to, I have a containment boundary on the outside of this part, and depending on if I'm inside, outside, or whatever, that jagged motion I was talking about, it's basically allowing it to fit kind of maybe an extra pass or reduce a pass, depending on what you have your compensation side set to basically ensure that smooth tool motion as it transitions from where I'm not allowed to cut to where I am allowed to cut. And another one, I was talking about the model chamfer tool path. Since we added that technology in to 2019, it is available for our multi-axis customers as well, and it's called deburr. And I won't get into that one because it would take a little longer for me to show, and we're already at 10:55 here. But it works the same way. It supports ball nose end mills or lollipop style cutters, and you can basically deburr an entire 5-axis part in a single tool path. And the same way as the 2D one or 3D one that I was showing earlier worked, in that you basically just assign a model or a distance to stay away from the model on the lead in, lead outs, and you can take care of it all in a single shot. And one smaller thing I wanted to mention is, although a lot of people have been using OptiRough, a lot of people will still use the area clear tool path. So if I go into OptiRough here, and instead of OptiRough, I would go to area rough. And the one complaint we would get when people would use area rough was the processing time. But from the testing I've done and from what I've seen at the people at corporate, area rough is roughly about 66% faster than what it was in 2018. So, something that would take 3 or 4 minutes to calculate is down to a minute and a half. So it's fully multi-threaded like dynamic OptiRough has always been. So the last part I want to cover here is turning. So let me launch a poll real quickly here first. Have you heard of prime turn? I know we've done a few events here locally. I'm not sure if they've done any down in Indiana with the Sandvik people. And there's a video I can link you guys to as far as what prime turning is, but essentially it's a proprietary cutting format from Sandvik where they basically kind of reinvented the way that turning could possibly work, where its main cutting direction is actually cutting away from the spindle of the machine. And that may seem counterintuitive, but without getting into too much detail, we've seen customers get, it's kind of like when high-speed machining first came out. Everyone was like, what's this? I'm used to just hogging at 50% width of the tool at, 50 inches a minute. And, as people got more and more into the dynamic tool paths, they really saw where the benefits can lie. Obviously there's still applications for traditional style tool paths. Same go for these. And most everyone's answered, so I'll close that out. So I have just a simple tool path here for the prime turn, but essentially what it does is, and it's their own, they have an A style and a B style of these inserts, but it essentially starts into the part and then pulls away. So you get this really long cutting edge as far as how the tool works. But the main difference in 2019 and why maybe a lot of people might have not heard of it or tried it in 2018 was that it ran as a C-hook and you had to contact your dealer in order to run it, and you had to install files in multiple locations in order to get it to work. Where in 2019, it's just now fully into the interface and called Prime Turn. And on Mastercam.com, if anyone has their account linked there, there is under the community section where you'd find the Mastercam forum, which is a very handy tool to use. And a lot of corporate people are on there as well as resellers answering questions. There's full tool libraries already built with all the Sandvik available Prime Turn tools and inserts in there. So you can download that tool library, drop it into your lathe folder in Mastercam, and basically start playing with how these tool paths work. And typically how we've worked with our Sandvik people here in Chicago is I'll get in touch with my customer, find out who their Sandvik sales guy is, and basically help them with a time study to see if it would be beneficial, see if they have the right machines and setups available. You know, since you're cutting away from the spindle, you want to make sure you have a tailstock or really good gripping force on your spindle, maybe a steady rest as well if it's a longer part. So there's definitely some factors there that the Sandvik guys will help a lot in determining if it's a proper application for you to try out the prime turning. So really my main point there is that it's baked into 2019 and I think it'll be easier for all of you to try. So the last two main things, I know we're getting close to noon here in Indiana, and I'll try to get through them here pretty quickly, but I think it's pretty important on the lathe side. Let me open up my last example file here. So I have just kind of a sample demo part. I think we originally came out this when we came out with the dynamic roughing. But a couple things in here. So first off is 2019 for all lathe users offers 3D tool support. So what does that mean? So if you have something like, let me minimize all these windows I got open, something like the Machining Cloud. If any of you guys aren't familiar with the Machining Cloud, it's a free app you can download. There's a ton of tooling manufacturers on there. And if you look in here, you can see, you know, a lot of the big names are on there. Sandvik has their own separate called Coro Plus, but both of those now you can import tools directly from either the Machining Cloud or Coro Plus into Mastercam. And while it was nice, what was missing on the lathe side was 3D tool support. So, you know, I have a Kennametal tool in here as an example, but I basically downloaded the step file and imported it right into 2019 from the Machining Cloud. And basically my end result here is I have a tool that looks like this. So we can bring in basically anything that the tool manufacturer has for the tool. I just have a simple stick tool as an example here, but it'll support Capto or any of the other style of holders that are out there. And when you bring the step model in, when it comes from the Machining Cloud, everything's in here as a single step file. So really the only thing I have to define here is what my insert is. So I picked on the yellow part of the insert, and then essentially everything else in the model was the holder. And then you walk through some other parameters here. You can expand, clicking the burger icon there on what these settings mean. But you basically define a cutting plane, which is the front side of the holder, the machine connection, which would be the top side of the holder. And then you get into the boundary of the tool. It automatically scans the 3D tool geometry, so it picks up those boundaries. So if I unshade here, you can kind of see the wireframe of the tool, which is how it would look in previous versions of Mastercam if you were bringing in a tool for people that even were using the Machining Cloud back in 2018. And then the last couple settings here and how it's oriented on the machine. And then lastly, what your comp locations are. You know, what's my plunge and cut directions? I can scan right from the tool geometry. So since we are bringing in this solid model, I can basically check those 4 boxes and it gives me all my clearance points for the tool that you're used to seeing if you've set up lathe tools in Mastercam in the past. We had a question there. Scott asked, are prime turn parameters still the same? Yes. I didn't get into the details there, but we have expanded, because the prime turn being so new, Sandvik's even learning new ways for applications and how it can work. So we've actually added a few more options in the prime turn tool pass from feedback of just people using it in the field and how the tool pass actually interface in Mastercam to what Sandvik recommends. But once I set all that stuff up, I have my tool defined, and the 3D tools work in both backplot and verify. So if I just go to backplot here, you can see it is representing that full 3D model of the tool. And this can be handy even in standard verify. Maybe you do have a stick tool like this with the clamp style insert holder instead of just a nut. And even regular verify will collision check to make sure that that additional insert clamp is not violating the part, where in the past you would either just have to know, hope, whatever it may be. And that ties into a final part of this lathe. So with the 3D tool support, and I don't have a poll for this, but and I'm not sure if we have anybody in the webinar that has it, but we've had the mill turn product that has mainly been for multi-spindle, multi-turret, upper B, Integrex or Malta style machines, where Mastercam has added in 2019 as an option. It's basically mill turn for standard lathe. And this PDF, it says it's confidential, but I'll just scroll down to the bottom part here, where they're going to have some generic machines to start, but then you guys will start seeing some more popular machines. And basically how this works is based on popularity. So anytime we get a customer request, this is how it worked with the mill turn environments, in that the more requests we can get, the faster we can get Mastercam to make environments for these particular machines. So it's using the mill turn technology, but in a standard lathe environment. So I haven't gotten any pricing information or anything like that on how it's going to work yet. But from what I've seen already, I think it can be pretty handy either for users that are new to Mastercam or maybe new to lathe, or even like Scott, our trainer, was saying, how many times have you set up a lathe, done the single block prove out on the floor, and then realized you had to move a tool locator from station 6 to station 8 because a tool was interfering with the part as it was trying to use a different tool on the turret. And back in previous versions of Mastercam, you'd basically either have to know that, tribal knowledge, or be very experienced on how you want to set up your machine. So the way the mill turn programming works is everything's essentially the same. About the only difference you will see if you add this on is on like your setup page here for any live machining. So I'm doing this kind of a dynamic slot mill there to rough out that slot on this part, and you get some kind of easier ways to define live tools. And the short story on this is that it can essentially automatically derive based on the solid model what your planes and everything like that are to do live machining. So it's definitely handy if you have a C and Y axis lathe. But where the big difference lies here is if I hit the post button, not verify, because verify will still kick me into the standard Mastercam verify. I can click post, and it actually sends it into what we call the sync manager. And you don't really have any syncing on a standard lathe. My example here is, I believe, a Haas ST25Y. But you do have some control in here over like approaches and retract positions. If you're running a production part, you can set up what's called reference locations, and have the part, the turret maybe move an inch off the part when it does an index to the next tool, and you can set all that up easily here in the sync manager. But where the real eye candy here is in the simulation. So basically we get the solid models directly from the machine tool manufacturers, set them up in Mastercam, and then we get something that looks like this. So you get the full housing of the machine, you get the spindle and turret set up, and for demo's sake here, let's turn off the housing. I can make the housing transparent, or I can make it completely disappear and just be worried about the tools in the turret. So you have, the various tools I set up. This is the 3D tool that I was showing you guys before with kind of a standard holder in there. And as I was programming this part initially, because I don't have any sample files from Mastercam yet for 2019, I did want to turn the housing on because my drill length was too long. So as it was using this roughing tool, the tip of my drill was hitting the housing of the machine. So that's stuff that you never would have known in just regular verify of Mastercam, because it's just showing the spindle and the tool holder. But as I run this, it's going to show, just like verify, all the material removal. It's going to show the direction of anyone that's used mill turn, some of this will be familiar, but it'll show you what the rotation of the spindle is like. Is it clockwise or counterclockwise? If I program tailstock into this particular part, it will show the motion of the tailstock, but I get all the indexes of the turret. I have this one programmed to just do, a home move between turret indexes. If I don't want to sit and wait for an op to completely verify, I can skip to the next op. It'll go right to the end of that live tooling that I was doing and hit run, and then it'll start showing the other operations I have in here. So I'm doing some drilling. It does the index. And I also noticed some issues when I was programming this. I had to move my drills around so that they weren't interfering with some of the boring bars that I was using. And then, you basically get a fully verified part. And I know before I ever send it out to the machine whether or not my holders are clearing and all that good stuff. And all that is set up in here in the operations manager. Right here, it's called setup tools on the machine. And you basically have all the tools used in the part and then where their tool locators and holders are in. So you have basically a default tool locator file that comes with each machine, but they're all just based off a solid model. So if you have custom tool locators, or you want to get really granular and start, I don't know if you guys noticed in the simulation I had, but I didn't have like the sleeves in there for my boring bars. If you want to add that stuff, you can. It's really just how far you want to take it as far as how the simulation goes. But we're going to be hearing more from Mastercam on what these environments and upgrades are going to be for existing lathe users. So I was doing a little presentation to our lathe class this week in our office here in Illinois, and some of the questions were the 3D tool support. That's for all lathe users. So anyone that has Mastercam lathe, once you fire up 2019, you'll be able to add and create 3D tools to your heart's content. But this full quote-unquote mill turn light, or whatever you want to call it, for standard lathes, that will be an upgrade for existing lathe users. And I kind of quickly jumped off that PDF I had, but if you're questioning whether or not your machine is supported, or maybe even we were talking in a meeting here, you just want to get the generic Fanuc machine and use that as kind of a clearance checker for parts, and then swap over to your standard Mastercam post to just send it out, that might not be a bad idea either. But I know I went about 10 minutes over here. We did start a couple minutes late. So Mastercam already has it up. It's what'snew.mastercam.com, and it has all the 2019 what's new in there on kind of a fancy, easy to use website. So if I go there, I can show you guys real quick. And so you can basically go by topic here, and they'll have kind of some expanded information depending on what functions we have. So as you can see here, there's a lot more stuff than I covered in the webinar today, but They'll be adding some videos in here. Like I was talking about, there's a video on the Mastercam forum going over that model chamfer toolpath in depth with Dave Canigliaro, who's the mill product manager at corporate. And they'll be adding to that soon. This is also kind of following a new format. Mastercam's hopefully going to be releasing an all-new website here pretty shortly. So again, I appreciate you all for attending.